We will be looking at the infrastructure and types of transportation involved in moving oil from its source to its end consumers. The logistics of moving oil from the upstream oil field to its end consumers is highly complex, involving a network of infrastructure and transportation operated by various market participants. From the oil field, crude is first transported by a series of gathering pipelines and accumulated in storage tanks. From there, it is carried either on rail, tankers, pipelines, or trucks to the refinery. The refinery then converts crude into various oil products such as liquefied petroleum gas or LPG, gasoline, diesel, and fuel oil, which are then transported to nearby product storage tanks. From the storage tanks, the refined products are carried to end consumers like retail stations via trucks, vessels, or pipelines. In the next few slides, we will dive into each of the transportation modes in more detail. Pipelines offer a low-cost, safe, and efficient way of moving oil, especially in landlocked locations. In terms of costs, pipeline transportation is the cheapest, followed by vessels, which could vary significantly depending on distance, followed by rail, and then trucks. The other advantage of transporting oil via pipeline is that it can be done around the clock. But pipeline transportation does not offer as much flexibility in delivery volumes as the other transportation modes, as they usually require a minimum booking volume and have a maximum capacity limit as well. The pipelines are subjected to corrosion over time, and for pipelines that run underground, detecting leaks and repairing them are usually difficult and can be more costly than above-ground pipelines. The other major disadvantage is that large capital investments are required for the construction of pipelines compared to trucks or vessels. Globally, the top 5 countries with the longest oil pipelines are the United States, Russia, Canada, China, as well as Kazakhstan. And would you like to venture a guess which country does the longest pipeline in the world originate? If you have guessed Russia, you're absolutely right. The Druzhba pipeline can carry 1.4 million barrels per day of oil every day and delivers oil from the eastern part of Russia to points in Ukraine, Belarus, Poland, Hungary, Slovakia, the Czech Republic, as well as Germany. Now, in comparison, the 2 countries that have the most extensive rail network in the world are the US and Canada. Here, we compare the differences in capacity, time, and cost in moving crude via rail and pipeline from Alberta in Canada to the US Gulf Coast. By rail, it takes around 3 days to move 70,000 barrels of crude and costs around $10 to $15 per barrel. In comparison, the proposed Keystone XL pipeline, which has now been scrapped, was designed to carry around 830,000 barrels of crude in a day from Alberta to the US Gulf Coast at around $5 per barrel. Now, it seems that the pipeline offers greater advantages than rail in every aspect. But why is Canada and the US still using rail to transport crude? First of all, rail offers more flexibility for volume variations. The cost of infrastructure is actually lower, and it can be expanded with lower barriers to reach new areas. So for this reason, the rail is sometimes preferred over the pipelines. Tankers offer an efficient way to carry oil over long distances on water. On the left, we have tankers that carry crude and refined products in varying sizes, from the small general purpose tankers that carry between 10 to 25 kilotons of refined products to the very large or ultra-large crude carriers, or what we call VLCC or ULCC, that can carry up to 550 kilotons of crude oil each time. Then the choice of tanker size depends on the volume of cargo to be shipped. One of the major advantages of carrying oil on large tankers is the economies of scale. It can cost much cheaper to carry oil on a VLCC compared to an Aframax on a dollar per ton basis for the same route. But there are limitations in that not all terminals are able to receive the large tankers, which means that the cargoes have to be transferred to smaller tankers to carry them to their end destinations if the restrictions are in place. On the right, we have the LPG tankers, which similarly range from the small gas carriers to the very large gas carriers. Unlike crude, LPG needs to be pressurized and refrigerated to keep it as a liquid. Hence, the gas carriers are designed to have tanks that can store LPG under pressurized and refrigerated conditions. Now, tanks are used to store crude and refined products as they are delivered across the supply chain. And there are four common types of storage tanks: the external floating roof tanks, the internal floating roof tanks, the fixed roof tanks, and the spherical tanks. An external floating roof tank comprises of a cylindrical steel shell with a roof that floats on the surface of the liquid. The roof rises and falls with the liquid level in the tank and helps minimize evaporation loss. The tank has a rim seal that is in contact with the roof parameter and is attached with the walls of the tank to create the seal and minimize emissions which would otherwise be a fire hazard. External floating roof tanks are commonly used to store crude. Now, on the other hand, you have the internal floating roof tank that has a fixed roof and an internal floater that rises and falls with the liquid level in the tank. The advantage of an internal over an external floating roof tank is that it can prevent the stored oil against weather conditions like rain, snow, or wind, and in turn preserve the quality of the oil. An internal floating roof tank can be used to store refined products such as gasoline and jet fuel, as well as liquid chemicals. Next, we have the fixed roof tank, which is similar to the internal floating roof tank, except that it does not have an internal floater. Fixed roof tanks are typically used to store products that have low volatility and flash point, which means that it does not vaporize and ignite easily, and examples of them are fuel oil or bitumen. Finally, we have the spherical tank that is used to store LPG under high pressure. The spherical shape of the tank distributes the pressure equally throughout the walls of the tank to avoid any weak points and leakage. With that, we've come to the end of the video, and we hope that you've enjoyed the session. Thank you.